We'll be on the 6, 5, 6, 6 homework, which was about graphing tangent and the reciprocal functions. Nothing? No questions at all? Because I have no problem jumping right into 7-1. I love this section. Can I do number 2? Oh, off of the quiz. Yeah, what did it give you? Is that the one where it gave you f of x and g of x?
Yes.
This is from the quiz, the last quiz. So they probably gave you something like f of x. It depends on your version, but one of them had cos x, and g of x was cos 5x on one, I think, and cos 4x on the other. And the question is, how does the graph of g compare to the graph of f, basically? And it said use, try to think about period or amplitude or phase shift or any of those to help you decide how these graphs compare. So what you kind of need to recognize is what this 5 does, right? Because this is the difference. This is the difference between the two equations. So what does this 5 affect as far as the graph of g goes? The period. It affects the period. It would affect the phase shift if there was a c here, but there's no c. So the only place that b appears in any of our formulas, right, I'm comparing this to y equals a cos bx minus c, right? 5 is my b here. The only place this appears is in the phase shift in the period. I wouldn't even worry about phase shift because there's clearly no c, which leaves only period to think about, and the formula for period is 2 pi over b. So let me calculate the period for f. Because there's nothing in front of the x except a visible 1, the period for f is going to be what? 2 pi. 2 pi. All right, so then in g, there's a 5 in front of the x, so the period is going to be 2 pi over 5. So one of the answers should compare f to g and talk about the period. And the one you want to select is the one that says the period of f is 5 times the period of g. Right? Because the period of f is clearly bigger. If you multiply this by 5, you get this. So the period of f is 5 times the period of g. That was the response I was looking for here.
Can we do one from the homework?
Yeah.
6.619. It's y equals 2 tan 4x minus 5.
Like this?
Yeah.
So this is number 19.
Yeah.
And 6.6. Okie dokie. So this is going to be tedious, but let's do it. We'll be given a view of nothing else. So when you're graphing tangent, what do I care about? Maybe you graph it differently, but when I'm graphing tangent, what do I care about? Period, definitely. And then we'll break that into quarter periods. And also I need to know the 0, where to start. The thing that the phase shift, the same idea as the phase shift. Okay, so let's start labeling A, B, and C. A is 2, B is 4, C is pi. Right, positive pi because you switch the sign. So then to get the period of tangent, you do what? 2 pi? Who? Pi over b. Right, that's the formula for tangent, right? Because the original tangent graph is period pi. So for the period of this more complicated tangent graph, you do pi over b, which becomes pi over 4 in this case. When I find my quarter periods, I break this period, this new period, into 4 equal pieces, so pi over 4, but then again divided by 4. So this guy is 4 over 1. gets flipped up and multiplied. So pi over 16 is my quarter period. And the last thing I want is my new 0. Right? Normally, tangent has a 0 at the origin. Right? It goes through the x-axis at the origin. But that 0 is going to move depending on b and c. So I need to calculate what c over b equals, which is pi over 4, it looks like. So now we can start doing our graph. So this is where I'm going to start building my tangent graph. So I'm going to put pi over 4 over here on my x-axis. Now, probably because this is pi over 16 and this is pi over 4, I'm going to want to get a common denominator to make my calculations a little easier. So what would this guy become if I use a common denominator?
4 pi over 16.
Yeah, you have to multiply by 4 over 4. And then it becomes 4 pi over 16. So let me label this guy here. Here, I'll say 4 pi over 16. I forgot they didn't have the same denominator. Okay, so this is where I start, and this tells me to go left and right this many units on the x-axis. So these are my left, right. These will give me my important x values. So if I go pi over 16 to the right, I'll be at 5 pi over 16. And if I go pi over 16 to the right again, I'll be at 6 pi over 16. Since I'm here, let me go ahead and label my points to the left, my x values. When I go to the left, I'll be at 3 pi over 16, and then 2 pi over 16. And then, how do I get points? Right, I've labeled x values, but I need actual xy points.
You need something right before the asymptote.
Right, so I know well, I kind of go back to the middle here. I know 4 pi over 16 is my 0. I know that's where I start. As far as asymptotes go, you have to go 2 quarter periods to get an asymptote. 2 quarter periods. So that's fine. You can go 2 quarter periods. Asymptote, asymptote. But if you go 1 quarter period, what happens? You go up to A. So A, this A value of 2 tells you how high to go after 1 quarter period, and the opposite of A tells you how low to go when you go to the left. So when I go 1 quarter period, I'm going to go up 1. And when I go back 1 quarter period, I'm going to go down. So I get something like...
Isn't it 2?
2! Oh my god! 2. Look, I was going through it anyway. That's how good I am. And it's got to go up. Yeah, it's supposed to be 2 definitely. That's 1 period. I don't know. How many did it ask for? 1 or 2 periods? Just 1? Sweet! Life is good. So you start from your 0, which you get from C over B. Then 2 quarter periods, you get an asymptote in any direction. 1 quarter period, you get out A.